So good afternoon, everybody. It's my pleasure again to be here. Can you believe it's 1 year already? When I prepare my slides, I could not believe that 1 year has passed. So I'm going to tell you a little bit about our office, which is the System Integration and Analysis Office, and present you the different calls that we will have for you this year. In addition, after I would have talked, I have Sue Lesica, who is going to give you another call for NSUF 13 on corrosion and on metals, and she's going to present you something that is linked to my office. So let's see. Last year, I think it was very useful for you to see a little bit the organization where we are. So we are in the Office of Fuel Cycle Technology. My boss is John Ersek, and you have different offices. So my office is NE51, as you can see, but we have also NE52. Bill McCoy is here. You don't see him, but he's here. Bill Boyle is NE53, everything related to repository science, basically. And we have also Melissa Bates, NE5, which is more storage and transportation. So today, the call, this is what you're interested in, are going to focus on material recovery, waste form, and also fission products, gaseous fission products. And we will have also a call FC11 on electrochemistry, and I will go through that. The material recovery and waste form campaign, basically, we are trying to develop advanced, robust separation technologies. We try to minimize the process. We try to minimize the waste. We do not want to have any proliferation concern. So that's the goal of this campaign, to have something that is robust and easy to implement. We have different, I will say, several R&D areas in the material recovery and waste form campaign. The first that I'm going to talk about is the Sigma team for advanced actinide recovery, STAR. I think that sounds good, huh? Don't you think? So we are focusing on the actinide and minor actinide recycling. So we'll have one call this year, but it's a general call, so read carefully through the lines. We'll have two calls on the off-gas Sigma team, and one is, you know, when Bob Jubin sent me the call and this rubidium thing I never thought about, and Kim Gray is here with me in the room, we never thought about that. It's fascinating, so you will see the call. And then we'll have a call through electrochemical processing. Stephen Kong is not here today, but if you want, he's the manager for electrochemistry. So let's see the electrochemistry separation. So read carefully what you have under your eyes. We are not focusing on capturing fission product from electrochemical process. We want to understand what fission products are doing in the salt. So Mark Williamson and Stephen here give you two examples. They give iodine and tellurium. That's two examples. You can think to something else. In the molten salt, we want to evaluate the chemistry to understand how they behave in the molten salt. Yeah, this is what I said. So molten salt, fission product, behavior. How do they behave, this fission product, into the molten salt? So that's the first call. The second call is focusing on separation. I should not say separation. I'm sorry. God, they're going to kill me. Material recovery. So look at the right side of your screen. We have dissolved a light water reactor. We're going to put that in nitric acid, concentrated nitric acid. We dissolve, and then we have two paths. That's the two paths that we are investigating right now. If you do not, if you are not familiar with the campaign, I really encourage you to talk to our point of contact, either Jim Brazy, who is here, or Terry Todd from Idaho National Lab. They will help you. They will brief you about the campaign. Do not try to invent something new. try to stick with us where we are right now. As you see here, we have an example. This is the Alcem process, the actinide-lantanide separation process. We need still fundamental data on this process or another one that could be applicable to what we're studying: thermodynamics, kinetics, role of complexants, how they're going to limit the transfer of one species from one phase to the other one. And when you turn to the other page, we have also all the radiolysis, gamma, alpha radiolysis. This is really very important when you talk about reprocessing, to understand what are the radiation effects on your solvent, how you can recycle or not resolvent, how these radiation effects create byproducts that can impede your extraction process. So that's the second call. Then we have waveform. Waveform development, point of contact is Kimberly Gray. The technical point of contact is John Vienna, PNNL. And I'm sorry, I'm so hot. You have no idea. Woo! Next time we need a fan. We're going to focus this year on waste glass and melts. So they would like to know more thermodynamic of the waste glass, a database model for the thermodynamics that can assist the formulation of glass. You know, when you have glass waveform, this is very important to formulate. When I talk, for example, to EM, Albert Kruger, who is a specialist in glass, is always telling me, Patricia, we do not know anymore how to formulate a new glass. So we're losing this kind of expertise. So this call is really on waste glass. I need you to focus really on thermodynamics data that are missing for this waste glass form. And as you can see, composition region for commission high-level waste glass. So read carefully. If you have questions, Kim and John Vienna will be able to help you. Then we have two calls. So it's written advanced waveform, but it's more gaseous fission product. So we have tritium. I know it's difficult to separate tritium from water. We need you to find a solution how to separate tritium and its titrated water from normal water. Anything you think of, a new process to separate this tritium would be welcome. So that's the first call. The second call is going to focus, like I told you, and I'm fascinated by the call. Too bad I cannot write anything anymore. But we have EPA regulation in this country. If we are very serious and we want to reprocess, we need to implement some, we'll say, capturing, immobilizing some fission products. Some of them are tritium, krypton, carbon-14, xenon. We need to understand how they are, how to capture them and to immobilize them because of the EPA regulations. So here is an example. Okay, I have a krypton. I'm going to trap krypton. Good, I have the methodology. Unfortunately, krypton is going to decay into rubidium. And rubidium 85 is very corrosive. So when you look at the call here, we need to find a method to, I will say, trap this or to understand how this rubidium, which is the decay product of krypton, is going to react with your storage, your container, because it's very corrosive. So that's our second call for the gaseous fission product. Then I'm going to give the floor to Sue Lesica, and then I'll come back.
Hello, my name's Sue Lesica. The topic I'll be talking about this year is a combined fuel cycle and NSUF topic. So in this case, funding for the researcher, whether it be the PI, co-PIs, will be funded by fuel cycle and will be limited to $500,000. The funding for the use of the capabilities of the NSUF and the NSUF partner facilities will be paid through separate funds. So now moving on to the scope of the topic. I am the federal point of contact, and the technical point of contact is Stuart Malloy from Los Alamos National Laboratory. So this year we're looking for proposals to develop advanced joining techniques for oxide dispersion strengthened steel. These steels are of interest to us because of their really great capabilities, mechanical capabilities in the very harsh environments of nuclear reactors. Part of what facilitates these great mechanical properties is their very complex microstructure. The challenge there is maintaining that microstructure at the joint in order to maintain the mechanical properties. And that's what we're looking to do research on through this scope. So we're looking for proposals to develop advanced joining techniques for ODS seals, which will maintain the mechanical properties of the base metal in the joint. We're also looking to develop a better understanding of the microstructure and what's going on in the heat-affected zones. If you have any questions, I'd be happy to get them, as well as you can send them to Stuart Malloy.
So I'm back. Well, some advice. You know, I've been in your shoes. I wrote pre-proposal and proposal and UP. You're going to put your heart in writing your proposal. How can you get a successful proposal? How can my team and I select you? Because there's something more. So here are a few secrets. You don't want to write your proposal alone. Team up. Please team up. We're not here to compete. We're here to make good science, great science, to have good results. So please team up with the people. You don't want to avoid the students. The goal of the NEUP is to engage the students. This is the workforce. This is our future. They need to be trained. Another advice, try to team up with the national labs. Like I told you, here you have the name of the point of contact, the technical point of contact. These are laboratory people. They will connect you with the national labs. If you don't know, come to me. I will connect you. That's the secret. Try to engage other universities, the students, the national labs, and maybe the industry. Then you have the three winning situation. Also, what is important for us, it's to be close to us. It's very good to think out of the box, and you're going to have a blue sky call. But here in this call, we need you. We need you because, and I'm sorry to say that, you do not cost so much as a national lab. That's the first thing. And we need you because you're going to provide us some fundamental data that are very important for the campaign. And you're going to be part of our campaign. We have meetings once or twice a year. You're going to be part of the meeting. You're going to be invited, and you're going to make some connections, and you're going to grow, and your students will go to national lab. There will be some exchange. So that's very important. What did I say? Well, here are the points of contact. I put for you the different points of contact that you can ask questions. Feel free. We're not far away. We're in DC, but we're not in this golden tower. We're close to you, and we want you to be engaged with us. This is very important. You know, in this field, we were maybe 8-10 years ago really down, and Terry Todd will tell you that we were kind of, I don't want to say unknown, but we were in a nebulous area. In this 8-10 years, we have grown so much. The material recovery waveform, the publication, the recognition, internationally, it's incredible. And it's not thanks to just one or two people. It's thanks to you. It's thanks to the partnership we have with you. So I wish you all the best. Do not be discouraged. You will put all your heart. You may be selected for the pre-proposal. You will think hard, oh my God, I'm going to get this proposal funded, and at the end you will not. Do not be discouraged. If I could fund all of you, I will. We're limited by the budget. That's the problem. But keep faith. I mean, one day or another, your work will be recognized, and I thank you so much for writing so good proposal. It's a joy to read some of you. Thank you very much, and if you have questions, I think Drew will take your question. Thank you.
Patricia, 2 questions.
Yes.
Are electrochemical separation technologies that operate in aqueous environments of interest under the call? I believe this was put in during the FC.
Yes, 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 would be of interest, yes.
Okay. And are zirconium dioxide waste forms of interest under the call?
No, it's only the glass waste form.
When and how do we get information about the blue sky call for proposal?
Blue sky call is going to be soon. It's my colleague Bill McCaughey tomorrow at 3:30.